2013 Civil Engineering Question 51. For a portion of national highway where a descending gradient of 1 in 25 meets with an ascending gradient of 1 in 20, a valley curve needs to be designed for a vehicle traveling at 90 km per hour. The headlight side distance equal to the stopping side distance of a level terrain considering the length of valley curve as greater than SST and the comfort condition with allowable rate of change of centrifugal acceleration is mentioned as 0.5 meters per second cube. Assuming the total reaction time as 2.5 seconds, coefficient of longitudinal friction as 0.35 and height of headlight as 0.75 and the beam angle is mentioned as 1 degree, what is the length of the valley curve based on comfort condition? The relevant NPTEL reference has been listed. When we design a valley curve, there are two conditions that are namely used. The first condition is side distance and the second one is comfort. The students are encouraged to watch the question number 50 video of 2013 itself to study the side distance criterion which has been discussed, as this is a part of linked comprehension question. For the comfort criterion, the length of the valley curve is given as 2 into square root of nv cube by c. Here n is the change in gradient which is taken in percent, v is the velocity in meters per second, c is the rate of change of acceleration which is taken in meter per second cube. On substituting these values, the length of the valley curve is obtained in units of meters. In this case, the value of v is mentioned as 90 km per hour. Converting this to meters per second by operating it with 5 by 18, the value would turn out to be 25 meter per second. The value of n can be found out by adding the two gradients n1 plus n2. n1 is mentioned as 1 in 25, which would be 100 over 25, that is 4%. Similarly, n2 would be 1 in 20, that would become as 5%. So adding these two values, it would become 0.04 plus 0.05, that is 0.09. Substituting the values to obtain the length of the valley curve, which is 2 root nv cube by c. So n in our case is 0.09, v was obtained as 25 cube divided by c, which is mentioned in the problem statement as 0.5 meter per second cube. So substituting the values, the length of the valley curve is obtained as 106.066 meters. This can be rounded off to 106.07 meter. This length of the valley curve was obtained based on the comfort condition. So the length of valley curve based on comfort condition was obtained as 106.07 meters. The relevant NPTEL reference has been cited.